Hello, today's problem is 987 vertical order traversal of a binary tree. I already coded solution. I tried actually doing DFS because I didn't know that I knew it but I didn't complete the reading the problem statement, and it says if the cells have the same kind of level and the same offset, then it means that they should be ordered by their values. Like in this case, 5 and 6 they are already ordered, and in this case 6 is and 5 they are not ordered. So I should change their um, their position. So like 1 and then 5 and 6 should be ordered because they are on the same kind of cell, the same level and the same offset, and those values should be ordered. Okay, let me code the solution and I'll try to optimize it even further because I have the hypothesis that this can be done only for there can be like either one element on the same cell, same row, same offset, same level, um, or there can be one or like none. So let me code the solution. So I'll do BFS and I'll have two queues. So I'll have queue int meta queue equals new linked list, and then the main queue. Yeah, and then I'll do uh, the root element gonna have like uh, level 0, offset 0. And then I'll have also a couple of hash set for the integer, and then array list here for the integer, and here I'm gonna accumulate the result. And then I'll also have int min offset as minimum initially, and int max offset as maximum offset. I'll make the range from minimum offset to maximum offset um, excluding, like currently it's empty because min is greater than max, because I need that for the root equals null. And then I'll do while q not empty. Here is a question: can it here be more than two elements? Let me try to guess. 1, 2. 0. Say we have like set, say. Okay, let's have this pairs assigned. So initially this one gonna have a 0 level, 0 offset. This one gonna have first level -1 offset. This one gonna have first level +1 offset, and then this one gonna level 2 offset or -2. That's gonna be level 2 offset 0. That's gonna have level 2 offset 0. It's gonna level 2 offset 2. That's gonna have level 3 offset -3. That's gonna be 3 offset -1. Gonna be 3 offset -1. Gonna have 3 offset 1. Gonna have 3 offset -1. Gonna have 3 offset 1. 3 offset 1. 3 offset 3. So as you can see, we have already like 2 plus elements on the level, on the same level, on the same level, and the same offset. So here we have like this element, okay, like this element has the same level and offset. This element has the same level and offset, and this element has the same level and offset. And the same happens for other one. This one has the same value and some offset. This one and this one. Okay, so I wanna have also here this one were just 2 elements. So I need to have the size also here. Today we have hash set integer, and then the first key gonna be level, and then next one gonna be hash map integer, and here hash map is gonna be offset, and then this one gonna be actual size, and this gonna be called size map. Size m equals new hash map, something like that. So I'll do here int l size equals q.size for l size l plus plus, and I'll do here the following. I'll do q.poll, and then it's gonna be integer. Oh, it's gonna be tree map. Oh, node, and then int meta gonna be meta q.poll, and if node equal null, I'm gonna continue. While I'm gonna have this, the main branching here is queue.offer node.left, and then new int, and then here I'm gonna have int level equals meta 0, and then int offset equals meta 1, and then here I'm gonna have level incremented and then offset -1, and do the same queue offer node dot right, new integer here, and then level +1 incremented and offset +1. That's it. And then I need basically insert the current node value into the right array here, and also I need to update the size of that array at the right level and the right offset. So the first one I need to get is the array itself. So accumulator, okay, in no, offset, actually offset, and then new array list. Int size, in this case, in, let's say, hash map, um, integer, and then offset level size. Cell size for offset equals size map get or default again, and for the offset, and then new hash map. And then int size equal cell size for the offset get or default, and then yeah, I need the first level, and then here offset, and then here 0. Okay, and then what I need to find is the right place I need to insert the node value. So int index to paste equals. So I have the basically array, and if size equals 0, then I need to return inserted 0. Otherwise, I need to do a search starting from the right bound. Say search. So the left bound gonna be something left bound. So I need to search for the node value, insert, and I need to insert right before the value in the array within left bound and right bound indexes that is less or equal that node value. So let's say we need to insert, I need to insert 5, and I have the following array. 1, 2, 3, 4. It's aligned. Let's say 5, 5, and then let's say 6, 7. And the bounds like from 4 to, so the indexes. So there it's index and then value. So let's assume I need to insert 5, not the value 5, and then left bound should be like 3, and the right bound should be, let's say, 7. And the right bound should be always like the end of the array, the size of the array minus 1, and the left bound should be based on the what size we have right here. Yeah, and so if I wanna insert in this range, I wanna insert right like here. So I want to return index 6 in this case. So I'm gonna insert 5 here, and the size gonna be incremented, and yeah, that's it. So I need to search the index for the node value to be inserted with the left bound and right bound, and I wanna search in the array A. Let's figure out what's the right bound first. Right bound gonna be size minus 1. Left bound in this case gonna be A dot size minus our size. So let's say we have like array with indexes 1 and 0, or 0 and 1, and I want the size is equal 1. So in this case, the indexes that bound gonna be size 2 minus size array total size minus 1, the size I wanna use, and the index gonna be starting from the first. And then what I wanna do really here, I don't wanna do like incremental search, because those values gonna be ordered. It's partially ordered array with chunks of size. So I wanna have this pretty function private. I'll call it bs index int bs index, and I'm gonna have node value, and then int left bound, int right bound, and then array list integer a. And then what I wanna have int good and bad equals left b minus 1, in good equal right b plus 1, and then while good minus bad greater than 1, I wanna do the following. I wanna do int middle equals bad plus good minus bad over 2, and then if a.get at middle greater than, if let's say it's less than or equal value, bad equal middle, else good equals this one. And I want to insert it right before the bad, right after the bad, right after the bad. So I want to return bad uh, index. Yeah, and then change it to this one. And then I want to a dot add and then index to paste and node dot value. And then I want to increment the size. And I want to put it back in case like it's not there. Cell size for the offset and size, put, and then size M, put to level, and cell size for the offset, and then finally a dot put for the offset, accumulator dot put. For the offset, I want to put the a, something like this. So let me give you a short overview. So I have like two queues. The first queue contains the nodes, TreeNodes elements, and the second queue contains metadata information. That's basically it's one-to-one. I could have created a pair and saved it in one single queue, but it's gonna be like faster here, like not faster but easier probably. And I'm gonna go like level by level here, and on every level, I'm gonna go through the TreeNodes on the level. I'm gonna return them from the queue. I'm gonna return the metadata for the node from the queue. If there is a null there, I'll do the. Actually, it's not yet the result because we need to return a list of ordered, like ordered within the offset. So for this purpose, I have min offset and max offset. So I need to update also min offset equals mass, that mean, and then finally I need to return for create a list linked, okay, list for the integer result equal new array list, and then I'm gonna have int I equals min offset I less or equal max offset I plus plus, and then I'm gonna put result add accumulator dot get I, and then I need to return result. So giving the short overview here, I'm gonna go level by level. As I said before, I have one-to-one mapping between node and meta in the queue, in the meta queue. Meta contains the coordinates of the node. The zero index value for the meta gonna have level um, number on, and the first index value gonna have offset number. So in this case, we have the first number is here is level. Let's see, like zero level, first level, second level, And the second number here is offset. Here is like offset 0, here is offset -1, offset 1, offset 2. The same here. Offset 0 comes like this element, and offset like 1, this, offset -1, this element, offset -2, this element, and offset 2 is this element. So let me quickly reiterate the solution. I have two queues. They have one-to-one mapping, the same number of elements. The first queue gonna have nodes. The second queue gonna have the meta information for the nodes. I'm gonna add the nodes to the queue to as this queue stands for the queue of TreeNodes to be processed, and um, uh, every level I gonna get the node from the queue. I'm gonna get the meta information from the meta queue. I'm gonna check if it's null. Actually, if it's null, I'm gonna continue. If it's not, I'm gonna get level and offset from the meta, and then I'm gonna update min and max offset, and then I'm gonna get the size for this cell by going this two-level hash map. And for the level 1, it contains like level as a queue, and for the second level, it contains key, um, like it contains offset as a key. And then I'm gonna get the size, and then the size gonna define the right offset for the array in the accumulator, and I need to, and those values within this offset of the array should be like ordered based on the problem statement. Sort nodes by their values. And in order to find the right value, like right index to insert, I'm gonna use binary search to figure that out. And then what I do there, I figure out the index to insert, and then I insert it as the index, and increment the size and put size back to the offset mapping, and then put the offset mapping to the size mapping, like level to offset mapping, and then I'm gonna put the array back to the offset map, and then offer left and right nodes. And also I need yeah, this is not okay. Meta queue.offer. And then again meta queue.offer. Yep, sounds to be right. Let me run it. Mm, no, I need to boot actually. No? Mm-hmm. Yeah, was small typo here. Hmm. Interesting. Why is it so bad? I guess it had a bad day. Leetcode has a bad day today. Much better for the memory. Mm-hmm. Memory distribution must be all over the place for this task. Yeah, let's discuss what I have what kind of other ideas I have for this task. So in this task, I didn't use anything fancy, just a queue, a linked list, and a hash map for the accumulator that's going to accumulate the result, and the hash map for the sizes of the cells. Cell, I mean the array that has um, the same level and the same offset, and within those cells, values of the array should be ordered of like a part array of array, and because of that I do the binary search because they are already partially ordered. I need to find the index to insert, and in order to do that I do binary search. So alternatives there, let me show you what I was thinking about before. So alternatives there, I guess, so that what's the timing? So the 33 minutes, so I guess it's fail because I have one error, and also I didn't code this problem within 20 minutes. So the alternative I had here is just um, do the what? Um, mm, mm. Yeah, this one is much more interesting. So this, what's the time complexity here? So the queue gonna have the maximum number of elements in the queue gonna be number of elements in the level, or number of elements in the current level plus next level, like some kind of that combination. And so the time complexity gonna be that one. Plus, I need to do some binary search, so gonna be log of size of the subsize of this level. And on the level, I'm gonna have uh, some some nodes on the level gonna receive the same attribution to the cell, and then within the cell, I need to order those elements. So gonna if the number of elements in the level gonna be, let's say, maximum is gonna be uh, n over 2, like leaf elements. So the space complexity gonna be of n over 2 plus log. There is some portion of it gonna be let's say m, and then we need to do some kind of this one probably. And on every level, so it's gonna be on the last level, and on previous level gonna be plus n over 4 plus this remainder, and so on and so forth until 1. And then this gonna be type of n, and the time complexity I guess time complexity also gonna be of n. Yeah, we visit every node and like save the output here in the accumulator, and then I'm gonna go through that array and remap it to the result. That's it. The alternative way is to have this interesting priority queue approach, where I'm gonna just convert a tree into a priority queue, nodes in a priority queue. So the idea here behind this approach, we run that. Yeah, it's a little bit better for the runtime. Yeah, and we have here a pair class that has a tree node and a tuple. Tuple is basically row colon value. I guess value I can skip as a value. Can I skip the value? No, I cannot because I do. So initially what I do, I have this priority queue and I convert mm, tree to this to the heap basically by doing the following. I have a queue. If root not null, I add it. While queue is not empty, I get the size level. I'm gonna traverse it, and I'm gonna add the tuples to the priority queue on every level. And then I'm gonna order those tuples, and I'm gonna order them if the columns is the same. Column is like offset in my case, and row is a level. If the column is okay, if the column is not the same, if they're not the same, whoever gets the this one column is basically offset. So whoever gets the lower offset, I'm gonna go to the left of the array, or like to the beginning of the priority queue, to the head of priority queue. And if the offset is the same, I'm gonna check if the level is the same. If it's not, if it's the same level, I just order the values by the increasing order. If the level is not the same, the one that has a lower level goes to the head of the as a priority queue. And then I'm gonna convert the tree to the heap or priority queue, and then create the output, and then get the values one by one from the priority queue, and I'm gonna add the value, and I'm gonna add the first one, and then pull it until the same column, until the same offset, and basically fill the current offset array, and then add that current offset array to the output, and then move to the next offset. And this order, like total order in the priority queue, will order all the nodes within the heap. All the three nodes, or like all the tuples I have here, are gonna be ordered. Yeah, that's it. So as I said, the status is fail because I didn't manage to solve it within time, and within 20 minutes, and also had one logical error in the algorithm. So that's it.